Alright, welcome back. In this video we're going to see more for structures or for expressions more accurately. Let's get started with our Scala interpreter. Alright, Scala, that's it. We are in the interpreter. Very quick. Now we'll see different type of for expressions here. Okay, first one, let's get started with something like for in previous program we saw something like for I, and then you have that assignment operator, which is also method in Scala, like particular number 2 to number -1, something like that. Now let's see another one for I need loop control variable I 1 until 5. Okay, until 5. What do? Just print I. Okay, I. And after we print, we just have one comma and then a space. Okay, so what does this for structure do? I 1 until 5. When you say until 5, it doesn't include 5. Okay, 1 2 3 4, it stops at 4 because it's until 5, right? Not 5 is not included. Let's run it. 1 2 3 4. Okay, there's one extra comma there. That's fine. Yeah, so I 1 until 5, so 5 not included. Okay, next one, let's see another for I let's do this one. 1 2 5, 1 to 5, and then we do this one, dot reverse. Okay, reverse print I. Alright, so it's going to print from the reverse order. It's pretty much like a list now, right? Okay, and one more that we haven't seen but we saw in the previous video, just for review, is for I 1 to 5 print I. Alright, 1 2 3 4 5, because it's 2 5, 1 for I, that range is 1 up to 5 included. If you say until 5 not included. Okay, let's see one another one, and that one reads like pretty much like this: for I 5 to, let's say 5 to 1. We're going in a reverse order. Okay, now we're giving the step here. I should go from 5 to 1, and the step is -1. And if we do print I, if we do this one, well, what's wrong with it? Let's see what's wrong with it. We need to have this by here. Print I already 5 4 3 2 1. Okay, let's change the step, -2, and again print I like this. All right, 5 3 2 5 3 1. Okay, that's step. Another one which we'll have in the next one, we'll try to have 2 variables and see how it works. Okay, ready? For we'll have I is more like an external loop. That one goes from 1 to 3, and the internal one goes through 1 to 2, 1 to 2, and we want to print I, and then a comma J. Okay, and then would semicolon. Let's see, and we'll see. Okay, let's see. I going from 1 to 3. Okay, which is that I? That's actually this I. 1, 1, 2, 2, 3, 3. And why you have 2? Because for one value of I, we have the inner loop, which is it runs for j, it runs from 1 to 2. Like first time is 1, second time is 2. And again for I is equal to 2, j is 1. That's the first one, first iteration. J is equal to 2. That's the second iteration. And that repeats in the last set as well. Okay, that's two variables in the same for expression. Next one, we'll see a little bit of kind of condition here. Okay, and that condition is for I, okay, 1 to 4. Okay, if I is not equal to 3, I is not equal to 3, j is j goes from 1 to 4 if I is not equal to j. I is not equal to j. Ready? And we print I plus j plus. Alright, so what do we get? So we should not get any expression where I is equal to 3, and I is the external loop. Let's see. And inside j also goes from 1 to 4, but it will not cover when I is equal to j. First, I is equal to 1, j, let's see, j should go from 1 to 4. Since I is equal to 1, when value for j is 1, that is if I is not equal to j, so that condition is not satisfied, so that is not included, right? So j does only for starts from 2. Okay, and second time 2, and then j has to finish first. Okay, and j would be 3, j would be 4. So that's the first value of I, and this is the second value of up to here, second value of I, and j is going from second time it goes from 1 because I value of I is 2. Okay, 1 1 is not included because both are equal, and then 2 3 3 they are included, 2 4 also included because the check for the j is I is not equal to j, and check for I is equal to I should not be 3, I should not be 3, and then I should not be equal to j in order to have this printed. Okay, when I is equal to 4, j is equal to 1, they are not equal, and I is equal to 3, that's included. I is equal to 4, yeah, I is equal to 4, j is equal to 2, they are not equal, so that's included, and I is obviously is not equal to 3 here, and that I is equal to 3 is not included because I is equal to 1 set, I is equal to 2 set, and I is equal to 4 set we have, and I is equal j is equal to 3, that's still satisfy the condition, so that's included. When j is equal to 4, since I is equal to 4, j is equal to 4, this condition is not met, so that's not included. If you see closely, we have one set here, and then how many up to sorry, let's see one more time. There's a complete set, that's the set, that's I is equal to 4, this is I is equal to 2 up to here. Okay, 3 is not included, you can see that, and then I is equal to 1. That's it. All right, next one, we'll see some start value. Okay, for, let's say this one is pretty interesting. I is equal to 1 to 4, that's same like before. Start j is equal to 5 minus I. Okay, we're giving some expression for starting value of j, and j will start from start j to 4. Okay, what is the problem? For I is equal to 1 to 4, start j is equal to 5 minus I, and j is equal to 1 to, oh, j is equal to actually start j to 4. That's the one that we want. And print I comma j and one more semicolon so that we can distinguish. Okay, how does it work? I is equal to 1 to 4, and first I is equal to 1, so we have 1, and then j is equal to 5 minus 1, which is 4, so j is equal to 4 to 4, so that's basically 4 to 4 is just 1, right? For, well, that is not really an increment, so it can't really go. So second time, well, that's actually 2 4, so 4 to 4 is included 1 4 actually. Okay, and then second time it has I is equal to 2 and j is equal to 3, I is equal to 2, j is equal to 3, and j is equal to 4, 4 to 4, so it's 4 to 4 it goes 1, so that's interesting. Okay, well, that's something to remember. And then next time for I is equal to 3, and then j is 5 minus 3 2, right? 2 to 4, so you can see that 2 to 4 is going ranging, and that's how it executes. Next one, we are going to see something like interesting structure. Okay, some like yield. We use the keyword yield. Let's do this one. For I 1 to 4 yield. Well, that's very interesting expression. What do I square? Let's see where it comes. Yeah, 1 4 9 16. You're squaring some certain set of numbers. That's pretty fast and easy actually. And you can see it's a vector. It's an immutable vector. Okay, this immutable property is very important in distributed computing. All right, so now let's see what is left. I'm trying to see what is left. Okay, so basically we will have a argument that has like 0 or more. We'll have a method defined that can take 0 or more arguments. Okay, so defined some args, it takes args of type integer, or it could be 0 or more integers, and then it will return integer is equal to what it does. Perhaps sum is equal to 0. We initialize that, and then for each number that we supply for num in args, what do we do is sum is equal to previous value of sum is equal to sum plus num. Okay, sum plus equal to num means sum is equal to sum plus num. Okay, we close that for loop, and then we return sum, and we close one more. Now we define that sum which takes 0 or more integer and then provides the summation, right? Is the, okay, if I say, if I don't provide anything, I get 0. If I provide one number, I get probably 1. If I provide 1 and 3, I probably get 4. If I provide 1 and that's a syntax error because okay, that is right. That's not right. That is right. We're getting good. Are we getting good sum? Let's see. 6, 1, 7, 7 and 78, 85. That's correct. Okay, that's what it is. That's simple. We'll try one more method that does some interesting things. Sum of even numbers. Okay, let's see how easy it is to write such method. Alright, where sum is equal to 0, and then for any number that is there in that list, for num in numbers, for each number, that's what we're telling, if num mod 2 is equal to 0, that gives a test for the even number. And what we could do, sum plus equal to sum previous value of sum plus num, that is sum is equal to previous value of sum plus num, and we return that sum, right, and close that. Okay, we define that. What this method is supposed to do, it takes a bunch of integer value and then it filters. Okay, that's over here. If num mod 2, that's a filter, is equal to 0, that's a filter. So if the number is even, we add, otherwise we just skip the numbers. Let's try that. Sum of even numbers. Okay, 1, 3, where we don't have any even numbers, that's why the sum is 0. 1, 4, sum is 4 because we have only 1. 1, 4, 2, sum is 6 because we have only 2 even numbers. We give a something complex that is complex enough, and that should be right. Actually, if we see 12 plus 4 is 16, plus 6 is 22, 22 plus 8 is 30, plus 4 is 34. That's it. Right, so this completes our for expression. Okay, in the next video we're going to see while loop.